Okay, so let's talk about a really weird paradox happening in AI right now. We've got these models that are becoming, basically superhuman at all sorts of things. But a new study just uncovered this massive blind spot. It's a type of problem that even the smartest AI just can't seem to get its head around. I mean, if you just look at the test scores, everything seems amazing. The top AIs are absolutely crushing it, scoring in the 80s, even 90s, on these huge benchmark exams. We're talking everything from the bar exam to advanced coding tests. On paper, they look like geniuses.
But, and this is the big question, are they actually getting smarter? Or are they just getting ridiculously good at, well, gaming the test? That's the mystery we're really digging into here.
So, the core problem is something researchers are calling benchmark saturation. Basically, the tests we've been using to grade AI are getting maxed out. Think about it. If every model gets an A+, how in the world do you know which one is actually the best? And this isn't some far-off problem. It's happening right now, and it's happening fast. If you look at something like the chatbot arena leaderboard, which is a big deal, the gap between the number 1 model and the number 10 model got cut in half in just a single year. The differences between them are becoming almost meaningless. And this has people at the very top worried. I mean, you've got folks like OpenAI co-founder Andre Karpathy calling it a full-on evaluation crisis. The yardsticks we've used for years to measure progress, they're basically breaking. So how do you test an AI that's essentially memorized the entire internet? You can't give it a test it's already seen. So researchers got creative. They turned to something you can't just look up the answer for, insight. And their tool of choice, traditional Japanese children's riddles. They're called nazo-nazo. And these things are brilliant because they're not about what you know. They're all about how you think. They're specifically designed to lead your brain down the wrong path. And the only way to solve them is to have that sudden flash of inspiration, that aha moment, where you see the problem in a totally new way. For example, here's one. Now, your first instinct is probably to think about, samurai history, or maybe logical places someone might run and hide. But that's the trap. That kind of thinking will get you absolutely nowhere.
And here's the cognitive leap you have to make. You have to stop thinking about the story and start thinking about the words themselves. So, the Japanese character for samurai is actually made of two smaller parts, the symbol for person and the symbol for temple. So when the samurai cuts the person, you literally take away the person part of the character, and what are you left with? Temple. Pretty clever, right?
All right, so the stage was set for a big showdown. Researchers put 38 of the most powerful AIs out there up against 126 regular human adults. The challenge was a whole set of 120 of these super tricky nazo-nazo riddles. And the results were not even close. Humans, on average, got about 53% right. The best of the best reasoning AIs, they barely managed 27%. Even with all of their data, they were less than half as good as us at getting that creative spark.
But here's where it gets really interesting. It's not just that the AIs failed. The most revealing part is how they failed. The researchers actually peeked inside the AI's thought process, and what they found gets right to the heart of this blind spot. So we're about to look under the hood of an AI's brain, so to speak. You can see it reasoning, you can see it trying things out, and you can pinpoint the exact moment it all falls apart. So get this. Here's a log from one of the models working on a riddle. It's thinking, it's exploring ideas, and then, boom, it actually figures out the correct answer. It gets the wordplay right and generates the word Tabasco. It's right there in its own train of thought. And then this happens. In the very next step, right after finding the perfect solution, the AI basically says, nah, that's probably not it. It doubts itself, decides to rethink the whole thing, and just walks away from the correct answer. The researchers have a name for this, verification failure. And it's exactly what it sounds like. It's like having a moment of pure genius, coming up with a brilliant idea, and then having so little confidence in it that you just crumple it up and throw it in the trash. The answer's there, but the self-awareness to recognize it just isn't. This really all boils down to what psychologists call the feeling of rightness. You know that feeling when you solve a tough problem, that aha moment hits you like a ton of bricks. It's a powerful, clear signal that tells you, yes, that's it. For us, it's a giant neon sign. For these AIs, it seems to be more like a tiny flickering candle in a hurricane, easily ignored. And this isn't just a fun little quirk. This finding has some massive implications for where AI is heading.
It's about way more than just solving riddles. It's about what it actually means for a machine to truly think.
So what's the big takeaway here? Well, first, it shows us that just making these models bigger and faster isn't going to fix this problem. Real intelligence, it turns out, isn't just about processing information. It's about evaluating your own thoughts. It's about thinking, something called metacognition. And that's a huge gap right now. Future breakthroughs might require a whole new approach, something like an AI metacognitive psychology, to actually teach these systems to be self-aware.
And that really leaves us with the million-dollar question, doesn't it? It's one thing to build an AI that can stumble upon a brilliant insight. It's a whole other ballgame to build an AI that actually knows when it's had one. So can we ever teach a machine to trust its own gut, to have faith in its own aha moment? How we answer that might just define the entire next generation of artificial intelligence.